For meetings, 3 blocks of time. The sort does most of the work. But which sort? Pattern 9 of 10 in the NBX STUDIO dojo. Greedy. The shortest code in the whole series, and the one you're most likely to get wrong for a reason you can't see. Intervals is the loudest one, and it usually means meetings, bookings, or arranges. Schedule or rooms or how many at once. Merge or overlap. Minimum number of something, where you want the fewest. But if a choice now can ruin a choice later, greedy is unsafe and you want dynamic programming. And if you can't prove the local choice is always right, don't reach for greedy in an interview. Intervals plus a sort is the combination. The hard part is knowing what to sort by. You're coordinating a meeting room. For bookings came in 1 to 3, 2 to 6, 8 to 10, and 15 to 18. Some of those clash. The one that runs from 2 until 6 begins while the first meeting is still going, so those 2 are really one long block of time. Your job is to collapse the diary into the smallest set of blocks that covers everything. Intervals is sort, keyed on X0, sorts every booking by its start time. The lambda is Python's way of writing a throwaway function, and here it just grabs the first number out of each pair. Sorted by start. Now here's why that matters so much. Once bookings are in start order, anything that overlaps the current block must be the very next one along. Sorting turns a question about every possible pair into a question about neighbors, and that's the whole reason this runs in one pass. Then merge starts holding just the first booking. Next booking is 2 to 6. Does its start come before the current block ends? 2 is less than or equal to 3, so yes, they overlap. So we stretch the block's end to whichever end is later, which is 6. 1 to 3 and 2 to 6 have become 1 to 6. One block now covers both meetings, and notice we never created anything new, we only widened what was already there. Straight from the dojo. 1 to 3 and 2 to 6 overlapped, because B started before A finished. So what about the block 1 to 6 and the booking 8 to 10? They overlap. Or they do not overlap because 8 starts after 6 ends. Have a think and pause the video if you like a moment. Ready? They don't overlap. 8 comes after 6, so there's a genuine gap between them, and a gap means a new block rather than a wider one. Next is 8 to 10. Does 8 come before 6? It doesn't, so there's a gap. The else branch runs, and we append it as a separate block. 2 blocks now. That's the entire decision the algorithm ever makes. Overlap means widen, gap means append. One comparison per booking, and it never revisits a decision it has already taken. That refusal to look back is exactly what the word greedy means. Last booking, 15 to 18. 15 is well past 10, so another gap and it becomes a third block. Return merged, and the diary is 3 blocks instead of 4 bookings. The whole thing cost 1 sort plus 1 walk, which is n log n for the sort and n for the walk. The sort dominates, so the honest complexity, to quote, is n log n. Now change the question and keep everything else. 3 bookings this time. 1 to 10, 2 to 3, and 4 to 5. You can only be in one room at a time, and you want to attend as many meetings as you possibly can. Not merge them, not count the blocks. Attend the most. Same function shape as before, and watch what happens if you reach for the sort you already know. Sorted by start time. The earliest booking is 1 to 10, so greedy takes it and counts it. It began first, and taking it felt obviously right. But it runs all the way until 10, so 2 to 3 is gone and 4 to 5 is gone with it. We return and 1 meeting attended. And the painful part is that you could have attended 2. The code ran, it returned a number, and the number is simply wrong. Nothing crashed to tell you. So here is the question the whole pattern turns on. Sorting by start time just cost us a meeting. What should we sort by instead, to attend as many as possible? By how long each meeting lasts, shortest first. Or by end time, earliest finisher first. Have a think, and pause the video if you would like a moment. Ready?
Sort by end time.
Shortest first sounds clever, and it also fails, because a short meeting sat awkwardly in the middle can still block 2 others. What actually matters is who frees the room soonest. 1 character changes. X1 instead of X0, so we sort on the end time. Now the earliest finisher is 2 to 3, and we take it. Start is at least last end, so count goes to 1, and last end becomes 3. Next is 4 to 5. 4 is not before 3, so it fits, and count goes to 2. 1 to 10 finishes last of all, so it is considered last, and by then the room is busy. 2 meetings attended instead of 1, from changing a single character. It is worth knowing why that works because an interviewer will ask. Whenever you take the meeting that finishes earliest, you leave the largest possible amount of time free for everything that comes after it. Any other first choice ends at the same time or later, so it can never leave you more room. Which means swapping in the earliest finisher never makes your answer worse, and that is the exchange argument, said in plain English. Say that sentence out loud in an interview, and you have proved your greedy choice is safe. Here's the part that actually separates people, and it isn't the loop. Merging intervals? Sort by start time, because you want neighbors to be adjacent. Picking the most non-overlapping meetings? Sort by end time, because finishing early leaves the most room for everything after it. Minimum rooms needed? Sort the starts and ends separately, and sweep through them. Same loop shape every time, and the sort key is what changes. Get the key wrong and the code still runs, still returns something, and is quietly incorrect. That's the failure mode to be afraid of here. Greedy is the easiest pattern to write and the easiest to be wrong about, so hold on to one test. Greedy is safe when a locally best choice can never block a better global outcome. Merging intervals passes that test because widening a block never costs you anything later. Coin change with arbitrary coin values fails it because grabbing the biggest coin first can strand you, which is precisely why that one is dynamic programming. So if you can't argue why the local choice is always safe, say so out loud and reach for DP instead. For to go and do. Merge intervals is the one we just wrote. Insert interval is the same idea with one booking arriving late. Non-overlapping intervals is where you must sort by end time instead. And meeting rooms too is the sweep and the one that gets asked most. 3 things to take with you. The signal is intervals or scheduling. The move is sort first, then one pass with a single comparison. And the danger is the sort key because the wrong one still runs and quietly lies to you. Last pattern next. Fast and slow pointers, where 2 runners at different speeds tell you something no single pass ever could. Go and do merge intervals first.